We're done with the what we call ceramic and also metal, but before we go to the polymer, let's us recap a little bit about metal and ceramic. This for your midterm lah. So I put here metal first. Metal. When we want to talk about something, we have done metal, we have done ceramic. Let me put in blue here. Ceramic, and then today we want to talk to the polymer. Just give you the what we call the introduction about the polymer. Okay, so let's talk about the metal first. Just recap a little bit. What is metal? Okay, metal is basically anything that have a metallic element inside lah. Metal is like a substance. I don't want to write lah because you can see in the previous video about the ni lah. But basically, it's composed metallic element. Example of element, you need to differentiate between element and compound. Element is something that is you found in your periodic table. For example, aluminium. What else? This ferrum, and then what else? Copper, and so on lah. So it composed is a metallic element, and often also it can compose non-metallic. Okay. Example like oxygen, nitrogen, carbon, because all these things is non-metal under the periodic table. So you have, for example, if you combine carbon and ferrum, if you combine these two, you get the steel. You combine these two together, you get what we call steel. Okay. So the alloy. So this is basically one of the definition of metal lah. What we call material that is composed of metallic element. So you give some example, plus and often it also compose some non-metallic element lah. And this is also the definition for alloy. This is also the definition for alloy. Okay, because alloy is basically refer to a metallic substance that compose two or more elements. They must be alloy, must have a metallic substance. Okay, because you can have two things composed together, for example, plastic and also ceramic. You can have that, but we don't call it alloy, we call it composite. So in order to be under the alloy, you need to have at least one. Normally the major part must be in metal lah, metallic substance lah. So metal is this. So what is the characteristic of metal? For first, the metal, the atoms in metal is arranged in orderly manner. Okay, compared to the ceramic and the polymer. If you go here, what we call, let me put here, gold atom. Let me put here first. Let me find first. Gold atom. TEM. Okay, so if you look there, so that is gold atom view under the very high magnification lah of the what we call of the microscope. They use an electron microscope, so you can see here this is gold. So you can see the atom here, the individual atom is arranged very orderly manner lah. Compare this with the what we call with the glass, you don't see like this, it's just haywire. Compare this with polymer, you also don't see like this lah. See a totally different thing. So you have this crystal, the order in the packing of the gold atom itself. So that is one of the characteristics of the metal. The atom inside the metal arranged in orderly manner. Okay, and then it's relatively dense. If you look, you can have an order. For example, polymer also, they can have an order. For example, let's say you have something like this. What we call this is basically the what we call the glucose. Okay, so you have this. I don't remember lah. OH. Okay, so this is basically glucose, and you can have this repeat unit again and again. So by looking that, you can have a pattern of this repeating again. That's also we call it as like a pattern lah. it arranged in such a way, in order manner. But if you look here, compared to metal, for example, you have, let's say, ferrum atom. Ferrum atom is just like a dot like that lah. So this is a carbon atom, so it's like a dot like that. But you can see the carbon and also the oxygen, carbon and another carbon, they have like what we call, is quite far lah. They are, it's not really far because this is covalent bonding anyway. But in metal, it's not like this. It just go here side by side like that. It's very dense. That's why metal is heavy compared to the polymer. Because polymer, even though they have some order, because if you repeat this again and again and again, you still get an order. But then they are sort of like a void here because because in order to make like a molecule like this, there are many things involved lah. Because this cannot, for example, here they have what we call steric hindrance. Steric hindrance. But what does it mean is that when you see the molecule cannot just, for example, let's say methane, CH4, the simplest molecule. If you see this in 3D, in 2D it's like this. You have carbon and then you have ash. So this is in 2D. You learn in organic chemistry. But when you want to do it in 3D, so it's basically the C is here, and then you have ash, and then you have something like this. Something like this. And then something like this at the back. And then something here. So this is ash. Normally the dash one is at the back, this in the front, this on the planar lah, on the board. So they have like angle here. This angle, the reason why they possess this structure in 3D is because of the steric hindrance. This ash will try to I mean that to be away from the another ash so that they have this largest angle possible lah. So I don't remember, 104 something like that lah. I remember that. But basically that's the reason why some compound have that structure and so on. But in metal, it doesn't have like this. It doesn't really border like this because in metal it's not covalent bond. This, you learn organic chemistry, right? Okay, this C and H is covalent bond, meaning that it's what we call sharing the electron. So it need to make sure the hydrogen must be sort of like the reason why they try to not repel, mean that to be at a position far away from another hydrogen is that to reduce their total energy and so on lah. It's something related to the energy. So that's the reason why you get the tetrahedral. So let me put this thing, methane 3D. Okay, you can see here. It's not like when you draw, it's not like this, it's not like this. It's more or less like that. In reality lah, reality is more like that. So it's like pyramidal, sort of like this. There are certain angle. This is the maximum angle to this, and so on. But in metal, you don't have covalent bond. In metal, you have what we call the metallic bond. So it doesn't have something like this. So it's dense. So that's another characteristic of the metal. It's dense lah. It's dense. Okay, it's dense. And also, in terms of mechanical characteristic, let me put here. In terms of mechanical characteristic, it's relatively stiff lah, stiff and strong. Stiff and strong, yet it is ductile. Ductile means that it can, it can sustain a deformation, mean that the change in in strain, deformation without fracture. You have a paper clip, you can bend it without the paper clip, snap. If you have this polymer, if you bend it, it snaps. So that's what does it mean ductile. Ductile means that you can make it pliable, or other word, pliable, or malleable, whatever the thing. But even you want to see also it's like that. Okay. So it's resistant to fracture. Ductile means it's resistant to fracture, snapping. So that's why people use metal in what we call in construction and so on. if you make a bridge using sort of like concrete, it can snap. That's why in the bridge you have what we call, even though the bridge using concrete, inside the concrete you have what we call a metal here, a metal. Even though this concrete is ceramic. Ceramic, one of the what we call characteristic of ceramic is brittle. In order to what we call to compensate that, they put the metal inside. This we will learn later on in composite lah, why they put metal in the middle here, and so on. But that is the reason why metal is widely used in engineering construction lah, because it is ductile. It will not snap when you bend. Okay, so that is another characteristic of the metal. And then metallic element, metallic compound or metal have a non-localized ion, localized electron. What does it mean is that the electron, for example, this is ferrum, the iron metal atom. So if you want to draw what we call the electron for this, the electron in the metal, in the ferrum, whatever here, they can jump here and here. They can just move around. The electron in the metal can move around. Compared to this, in the polymer, like the methane here, or glucose here, this is covalent bond, this is covalent bond, this is covalent bond, this is covalent, and so on lah. So when you have covalent bond, you are sharing, so the electron, because what you share is basically you share the electron. So the electron cannot move around. But in metal, you don't really share the electron. The electron free to move. That's why metal can conduct electricity, because electricity is basically, that's why metal can conduct electricity, because metal have this non-localized electron. Non-localized electron, other word is mobile electron. It can move everywhere in the lattice, in the metal lattice. Okay, so that's why it have what we call metal is extremely good electrical conductor because of this reason, because of this non-localized ion. That's why last time people ask Nadra, Rauda, is all metal conductor? And as far as I know, I don't encounter any metal that is non-conductor lah. Some metal can conduct electricity better than other, but most metal, typically when we talk about metal, is conduct electricity because of this, because the nature of the metal itself, they have this mobile electron. And then in terms of optical, metal is opaque. Metal is opaque. Okay. Can you tell me any metal that is transparent? No? Any metal that is transparent. Okay. The reason why metal is opaque is something to do with what we learned before. Okay. We learned before the metal. If you look under the metal, you have a lot of grain. Grain. This is what we learned in previous, I don't know when. They are like a grain, and then you have this boundaries. This is crystal, metal crystal, and then you have boundaries. Because of this, it's not like a one solid chunk of the crystal. So that's the reason these boundaries, they sort of like what we call scatter the light here and there. Because the light come, it scatter here and there, so it cannot pass through lah. So that's why metal, most of metal, not most, I mean all metal is opaque. I don't think there are metal that is transparent. Yeah, I don't think there are metal that is transparent. Okay, and also metal have this what we call lustrous, shiny property. Okay, this doesn't share, other material doesn't share this, because if you look, no, some material share this thing. For example, if you have like glass, you can also have the shiny property. But but here I want to show you that the metal have this lustrous or shiny property lah. One of the characteristics of metal. If you polish the metal good enough, you get very very polished surface to the point that you can make a mirror. In fact, the mirror, the concept of mirror, you have a mirror. Mirror is basically metal, polished metal. If you see the mirror, in the front is basically the glass. The front is a glass. This is glass. At the back here is a metal. The one that reflect you can see you because of the metal here at the back, not because of the glass. The glass is just to protect the metal from being oxidized. Go and see any mirror and see from the side. You can have this glass, and then you have this what we call thin layer of polished metal, and then this is you see the mirror lah. The reason why they do like this is because by doing like this, you use a very little metal. Okay, you don't need a very chunky metal to make a mirror. So you just use a very thin layer of metal, and then you can make a mirror. So that is the properties of the metal lah. And then some metal have a magnetic properties. Some metal have magnetic properties. For example, like nickel, cobalt, and then the iron and so on. So this is basically the characteristic of metal. And then we learn about ceramic. We learn about ceramic after that. We learn about ceramic. Ceramic, by definition, is something that is between metal and metallic. So I put here like this. So ceramic is basically something that is what we call compound between metallic and what we call non-metallic. So normally is frequently consists of oxide. Normally consists of oxide, nitride, and carbide. For example, oxide we have learned before. Aluminium oxide, and then nitride is silicon dioxide, and then carbide is basically silicon carbide like that. Okay, so that is basically the ceramic, one of the metallic between. So let me put between. So definition of ceramic is a compound between metallic and non-metallic, and typically it consists of oxide, nitride, and carbide, and also plus what we call a traditional ceramic. Traditional ceramic is the clay lah. So it's the clay, and plus also the what we call, there are other two, plus clay plus cement, and also plus glass. So that's basically the definition of ceramic. What is ceramic is that lah. So as you can see, it's diverse. It's very broad material. Okay. In terms of mechanical characteristic, it's relatively stiff. It's relatively stiff and strong, meaning that it's comparable. So it's comparable to metal. It's comparable to metal, but the ceramic typically brittle. Okay, they are hard. Relative stiff and strong, and also they are hard. Okay. But one of the problem with ceramic is brittle. They are brittle. Hard doesn't mean strong. If you have what we call this diamond we know is hard, hardest known material, natural material. If you take the hammer, if you try to put this what I call this diamond in whatever thing, and then you take the hammer and then you try to smash this thing will shatter. This thing will shatter. Okay, this thing will shatter. It doesn't mean hard doesn't mean it cannot shatter. Hard is just the definition of hard. It can resist the deformation, the plastic deformation, like we learned in the previous class lah. If you try to hit this diamond with the hammer or whatever, it will break. It will not shatter. Okay. Okay, hard and brittle. Nowadays they are like, in terms of brittle, newly in modern days, a new engineered modern engineered ceramic typically resistant lah. Resistant mean that they improve over time. People engineer a ceramic that is not so brittle, like the what we call, like the coral or whatever, coral and so on. Coral is basically the name of the what we call. It's like last time we talked about Corningware. Last time we talked about Corningware. Corningware is basically the glass ceramic. This is glass ceramic. We have learned this in the previous class. Okay, the coral is basically is just another kitchenware like that. So this is coral. Okay, coral is basically a kind of glass ceramic also, not glass ceramic, but this thing is quite brittle resistant. If you try to sort of like, anyone have this in Farah? You have at your house? You have? You can just knock that thing. You will hear some what we call. If you knock this coral with your hand, you will hear a very distinct sound that is not the same as you knock this what we call, this ceramic. Okay, it have sort of like bouncy sound. I don't have coral here, but it's like more like, you know, the sound like a bell. You have like, when you try to knock, they have reverb. They have what we call the sound echo, something like that lah. So if you can try at home, you can try that, and also you try to sort of like to what we call, to drop that, not drop on the concrete lah, on any soft surface, it will not break lah, compared to the typical normal kitchenware, which is not coral. Then that kitchenware will break easily compared to this. This is what we call brittle resistant lah. Okay, so in terms of, it's also ceramic, in the properties of ceramic is insulative. Insulative to heat, and also the electrical ni. Okay, but it doesn't mean, because you see most the ceramic division is too broad. Not all ceramic is like this, but most ceramic is insulative to heat and also the electrical or conductivity lah. For example, not all like this. For example, diamond. Diamond is good heat conductor. Diamond is very good heat conductor. Okay. So this is just generic. This is just generic only. It's not cater all the ceramic. So that's another properties of what we call general properties of the ceramic. And also ceramic, one of these properties is what we call resistant to harsh environment. For example, in terms of heat or temperature, compared to other material lah. Other material, meaning that compared to the metal and also the polymer, the what we call ceramic is more resistant. More resistant. In terms of optical, okay, ceramic can be transparent. For example, the glass. Okay, and then it can also be translucent, meaning that you have a glass and then you scratch it, you get something like a frosty glass or whatever. So this is scratch glass. And you can also have totally opaque ceramic. Opaque ceramic. For example, bricks. Okay, so this is ceramic. This tile is ceramic. So that's opaque. That's opaque. And then some ceramic. Okay, some ceramic have magnetic properties. Magnetic properties. Some typically they are oxide lah. Some oxide ceramic. Some oxide ceramic have magnetic properties. For example, ferrum apa ni? Ferrum 304 like that. Okay, so some oxide ceramic have magnetic properties. In fact, most of the magnet that you see around you, I just take some part here. Most of the magnet, we can say like 3.4 of magnet in the world is basically ceramic-based magnet. Okay, ceramic magnet. Ceramic magnet. Ceramic magnet, they are different than rare because they have two types of magnet. Two big type. Either you have magnet. Sometimes you have this rare earth magnet, like neodymium, neodymium. I don't bring it today, but this normally this magnet is totally metal lah, and then you have ceramic magnet. Ceramic magnet. Okay, let me put here. So for example, if I put here rare earth magnet, so you can see something like that. Okay, so this neodymium. So normally you can see very shiny ni lah, because it's made from what we call from totally metal, and one of the properties of metal is shiny, it's lustrous. So that is neodymium magnet lah. This thing you can see something like this. That is a rare earth magnet. I don't know why it's rare, but it's just conventional lah. Ceramic magnet, but this is not normally used in industry because it costs very costly. So ceramic magnet 3.4, around more than half of the magnet produced in the world is ceramic magnet. Ceramic magnet is like this, the one that is black in color. Ceramic magnet, something like that. Okay, more or less the same, but normally it's like what we call black in color. Black in color like that. Okay. Toy magnet, normally they use ceramic magnet. Typically they use this in what we call, they use this in the DC motor. DC motor, they use this in an MRI machine. They use this in apa tu? Loudspeaker. They use ceramic magnet. They don't use this rare earth magnet. For example, if I use DC motor, you have that thing. Okay, so normally in the DC motor you have the what we call the magnet in between this thing. So if you ever open the motor, you have this thing. That is basically the ceramic magnet. The reason why people use ceramic magnet is because low cost. Low cost. And another benefit is that it can retain the magnetism even in harsh condition. It can retain magnetism in harsh condition. Normally when you have a magnet, when you try to subject it to the harsh condition, typically by heating it or by putting under pressure, the magnetism will become lower and lower. Ceramic magnet, they can retain the magnetism even in harsh condition. That's why they use this in motor, because in motor you throw the what we call the electric heat, electric to the motor. So that's why people use this what we call ceramic magnet in DC motor and so on lah. So how they make this ceramic magnet? The term ceramic, where the ceramic come from? Because we are the ceramic. The term ceramic come from this strontium apa benda nama dia? Carbonate, and then they plus with the ferrum oxide. The strontium carbonate, strontium carbonate. it's just like another carbonate, carbon stair. So that is strontium carbonate, but basically strontium is pretty stable. It's one of the it's one of the thing that you can find in the periodic table. Where is strontium? This one, this strontium here, strontium, one of the element in periodic table. Strontium carbonate, they make a compound with the carbonate. So carbonate, the thing carbonate, that is the ceramic, because ceramic you can see it consists metallic and non-metallic. So strontium carbonate is metallic and non-metallic. So this is ceramic part. Okay. So this is the metal part lah. So that's why they call it. The magnetism comes from the this metal part. So how they do it? They have this powder. How they make it? They have this powder and they mix them together. So how they make it? They mix this together. They mix and then they heat it. Mana? They heat it. They heat it. This process is called sintering. Sintering. What does it mean by sintering? Is that you have a powder. Let's say I have a powder here. I have the powder here. 1, 2, 3, 4. You have this powder. You want to fuse them together. So how to fuse them? You need to put a lot of pressure and also temperature. So how to fuse it? Tak nampak lah sini. So I put here lah. Let's say you have this 4 powder. Let's 4 powder. And then when you try to heat it, and then you try to put under pressure, what happens? You get something like this. Something fused like this. They have this fuse like this. And then you even further, you get something, a mass like that. This like hole lah, hole. So basically you fuse the thing using the temperature, temp, and also pressure. So this temperature that they use is not enough to melt the powder. So that's why it doesn't melt, it doesn't flow. It's enough to sinter. This is what we call sintering. You don't melt, you just fuse. So that's sintering. So still you can see the retain, the what called sort of like shape. It's not melting it. Because the temperature, you cannot put the temperature to the point that the thing melt. Because the melt you cannot put in the, ni lah, it's difficult lah. So that's sintering. And then you get the ceramic magnet. So that's basically the ceramic magnet. Okay. I think that's it lah for today. Amiro dah penat dah. Because I think if I go for polymer, I think better we go for the next class. We start with the new. So today is just like recap lah. This like more or less sort of like give you the brief overview again about what is metal, what is ceramic.